in your syllabus, there is collision in 2 dimension. I'm doing this for you, and I'll tell you the trick how to convert it into elastic collision, and then you need to find the loss of kinetic energy also in this case. So now you see that this mass m1 and this is the mass m2. They are coming at certain angles. See, the m1 mass is coming at this angle. Let me draw this. This is coming at this angle. This is u1, and this is coming in this angle. So it is in this angle. When I'll resolve it, it will be in this part. It will be u1 cos theta, and in this part it will be cos theta 1. Sorry, and in this part it will be u1 sine theta j, because this will be u1 sine theta j sine theta, and it will be the j component. That is, the j component will be here, so it will be along the y-axis. This will be in this direction. Let me of this. Okay, now this figure I hope you have understood. This figure has been understood, I hope so, by you all. Now देखो u1 इधर से आ रहा है, u1 इधर से आ रहा है, इसका एंगल यहाँ पे थीटा है. इसको रिजॉल्व करोगे तो u1 cos थीटा इस डायरेक्शन पे जाएगा और u1 sin थीटा इस डायरेक्शन पे जाएगा. And my x and y axis are in this direction. X and y axis, unit vector I is in this direction and unit vector j is in this direction. Fine. Now let's start. This is our reference frame. Now first I have to resolve u1. u1 vector. u1 vector will be u1 cos theta I cap, and take the u1 common out. This is, let me rewrite it. This u1 exactly. This is my u1. u1 cos theta minus sin theta j component. Now again u2. Similarly, I'll do it for u2 also. This one component. This is also coming somewhat like this. Now with some angle theta 2. u2, it will be cos. This is theta 1, and this will be cos theta 2 I cap minus sin theta 2 j cap. This is. Now V1, take V1. V1 similarly like this, there will be cos phi and this sin phi component. Now let me tell you like this. Your this is your V coming in this manner. This is, let me take V1. This is your phi 1, and in this it will be your this is phi 1 component. Sorry, not this way. Sorry, not this way. Sorry, not this way. Your This is the x-axis. This is your phi 1. So u1 v1 cos phi will be in this direction. Cos phi 1 will be in this direction, and sin phi will be somewhere in this direction. v1 sin phi will be in this. Sin phi 1 will be in this direction. I hope now these two directions are clear for this picture and this picture. Similarly for this. Similarly for this. Now v1 is v1 cos phi 1 I cap minus sin phi 1 some other angle j. And similarly v2 is your v2 common. You have your cos phi 2 I cap minus sin phi 2 j cap. I hope you understood the way you have done for u1. जैसे u1 के लिए किया वैसे v1 के लिए होगा. बस यहाँ पे थीटा 2 होगा. यहाँ पे थीटा 2 होगा. अब यहाँ पे v1 के जगह पे v2 आएगा. यहाँ पे phi 2 होगा phi 1 के जगह पे. ऐसे रिजॉल्व होगा एकदम. That's why these four equations. Now you will now use CLM, because now CLM can be used because there is no external force. CLM is used. Now you write down the equation m1 v1 vector. That's why I always use vector equation. m1 v2 is equal to, sorry, m1 u2. Extremely sorry. Let me rewrite the whole thing. It is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. No problem in this. Now, according to now, I cannot use that conservation of kinetic energy. I will use this equation. I hope I told you about this equation. Coefficient of restitution is your v1 minus v2, v1 vector minus, on the top I have written, on the beginning of the chapter I have told you, v1 minus v2 upon u2 minus u1 vector, u2 minus u1 vector. I have told you this. This equation I am going to use. I cannot use conservation of kinetic energy because this is a inelastic collision. And one more point I will telling you. Suppose you use this equation. This equation you can use also in case of your perfectly elastic collision. then do not use kinetic energy equation, conservation of kinetic energy. Just put equal to 1 and solve it and you will get the same thing. I'm repeating, do not use both this coefficient of restitution and conservation of kinetic energy in case of elastic collision. Either you use this or you use this or you use this. मैं ये कहना चाहता हूं कि अगर ये इलास्टिक कोलिशन होता तो या तो मैं ये इक्वेशन यूज करता या तो मैं कंजर्वेशन ऑफ काइनेटिक एनर्जी एनर्जी वाला इक्वेशन यूज करता, दोनों नहीं, कोई एक. बट वी आर डूइंग नाउ इन इलास्टिक, सो फॉरगेट अबाउट कंजर्वेशन ऑफ काइनेटिक एनर्जी. We don't need this. We don't need this. Now come to the point. Now let's multiply, cross multiply and do everything. Wait, let me take some space. Take some space. Yes. Now if you multiply this, you will get v1, wait a minute, you will get v1 v2 vector, v1 minus v2 vector, you will get equal to e times u2 vector minus u1 vector. Now see, put the values of all this, whatever I found out. I'm talking about these things. I'm talking about these points, these these vectors that I found out. These vectors that I found out. This all you have to put in their places. u1 के जगह पे u1 put करोगे, u2 के जगह पे u2. In place of u1 you will put this u1. In place of u2 you will place u2. In place of v1 you will take v1, and in place of v2 you will take v2. u1 के जगह पे u1, u2 के जगह पे u2, और v1 के जगह पे v1 और v2 के जगह पे v2. Now see what happens. Now see everywhere in both this equation, in this equation as well as in this equation. Now see, this will become, this equation will become, this equation will become now v1. See, Newton's. We will take the Newton's collision rule. This is the Newton's collision rule. See, collision is happening along the x-axis. It is colliding. You can see the picture. It is colliding on the x-axis. We will take it in this manner. Wait a minute. Yes. Just a minute. Yes. We will take it in this. The collision is happening on the x-axis. It is coming here. It is coming here. The collision is happening in the x-axis side. So according to Newton's collision rule on the x-axis side, we will take this. So let's write that line. That line is very important. Wait a minute. According to according to according to uh, Newton's Newton's collision rule, collision rule, collision rule along x-axis, along x-axis only. We are talking about this. So now in this case, this v1 now will have v1i component, v1i component, because otherwise things will become so complicated you won't be able to solve it if you take the generalized case. So let me take v1 I cap minus v2 I cap equal to e times your, it is happening along the x-axis. No, wait a minute, I did a mistake. Need to take, see, you need to take only the I components, that is v1. Wait a minute, you need to take v1, wait a minute, this is going to be v1 along the x-axis we are taking. If you do this also, it will come out to be the same. See what I'm doing. I'm doing a dot product with an I. Those up vectors, no problem. You can do this way also. And u1i dot product vectors. So what you will get? Cos you will only get I dot I, and I dot j will be 0. You can see here, see here that if you do I dot I with this, you do I dot I with this component will become 0. J component will become 0. J component, sorry, these J components will become 0. This J components will become 0. Let's come down. Yes, now you will have only V1. This is V1 cos phi 1 minus V2 cos phi 2 is equal to E U2 cos theta 1. Be very careful with the angles. U1 U2 cos theta 1, U2 cos theta 2, sorry, u2 cos theta 2, be very careful with the angles, and you have minus u1 cos theta 1. This is a very, very important equation. This is an important equation. Now, now the now you have to take the tangential velocities also. The tangential velocity at this point, this is another important concept you need to understand. The tangential velocity. What do you mean by tangential here? See, here they both are touching each other. So there is a tangent somewhere here. So the tangential velocity, that is u1 cos phi cos theta 1, and your v1, this for this, see the tangential part, I mean to say the y component of this u1 and the y component of v1 will become same, y component of u2 and y component of v2 will become same along this tangent. There will be a tangent somewhere here touching the two circles, I mean two balls, whatever, two bodies, whatever the two bodies, this part I'm talking about. Okay, now come to this point. Let me write down that line and so that you can remember. Wait a minute. Yes, we will write a line here. The tangential velocity, the tangential velocity. This line is very, very important to be written. Tangential velocity before, before and after collision are equal, after collision are equal because there is no force at right angle to the common normal, and there is no force at right angle to the common normal normal OX. Means, I mean to say this. See what I mean to say. Let's go back to the picture and see, this is my origin O, this is my x-axis. Sorry, I don't know why it slipped off. Wait a minute. Here it is. It is your x-axis. This is the normal, this is the tangent, and this is the normal. There is no force in this direction. So that's the thing. In this direction there is no force. Now you have understood. The tangent is touching the points and the normal. I hope you got the point. Let me now drag it down. Now because of this v1 vector dot j is equal to u1 dot j vector, and v2 dot j is equal to u2 vector dot j. There is no doubt about it. So here you will have v1 sine phi 1 will be equal to u1 sine theta 1, and here you v2 sine phi 2 will be equal to u2 sine theta 2. Now these are again more important equations. You can now, I think you should write down the equations name and all the thing if you want. Let's no need, you can just keep these equations in mind. These are the important equations. Now what you have to do, this equation, see, now you need to use this equation. Now I'll show you which equation you need to use. Now you need to use this finally. Wait a minute, just a minute. Yes, you need to use this equation. You need to use this equation that I have written. This one, I'm talking about the CLM equation. CLM equation you need to write down completely. You will have two component ij, you will have the ij component, ij component, ij component. Equate all the ij components. Now equate all the ij components. Now let's write it down. Let's write it down here. See what is happening. You have m1. What is what is u1? U1 cos theta I, cos theta 1 rather, cos theta 1 I minus uh, this is cos theta 1, and then sin theta 1 j plus m2 u2 m2 u2 m2 u2 m2 u2 m2 u2. You have cos theta 2 I cap minus sin theta 2 j cap. Now this is equal to m1 v1. v1, this you have, v1 you have cos phi 1. Be very clear about your angles. Cos phi 1 I cap minus sine phi 2, phi 2 j cap, and plus in this side only m2 v2 you have cos phi 2 I cap minus sine phi 2 j cap. Wait a minute, j cap. Now you see one thing, you need to use this equation. v1 sine phi 1, where is v1 sine phi 1? v1 sine phi 1 is this. This is 1, sorry, I made a mistake here. This is 1, this is 1, this is 2 2. Wait a minute, let me rub and rewrite this portion because there cannot be. This is 2 and this is j cap and the comma. See, now you have to equate the two sides. See very carefully. Equate the I and the j components. Equate I and the j components, I cap and j components. What you will get? m1 u1 cos theta 1 plus m2 u2 cos theta 2, I and the j, equate I and j from both sides, both sides. Now this will be equal to m1 v1 cos phi 1 plus m2 v2 cos phi 2, and the other one is of the minus everywhere, so you forget the minus sign. m1 u1 sine theta 1 plus m2 u2 sine theta 2 equal to m1 v1 sine phi 1, and you have m2 v2 sine phi 2, sine phi 2, right? Now this is what you have got. Now see this equation. Now in this equation, see sine theta 1 is here, sine theta 1 and v1 sine, so you need to replace them all with the same signs. It is easier. Do one thing, let's drag it down and let's see what I'm doing. See what I'm going to do. And wait a minute. Yes, no problem. With such big equations, you have some little problems. Wait, be very careful when you write down these equations. Let me keep them here. Yes, these equations I need. So now you write this m1 u1 sine theta 1. I'm copying this equation again. Plus m2 u2 sine theta 2, m2 u2 sine theta. Now in place of v1 sine phi 1, I will write u1 sine theta 1. See, so this equation sine theta 1, so they both are same basically. These two are same. So see, if I put this m1 in place of this, if I put this one m1 u1 sine theta 1, and in place of this, if I write, in place of this I write this one, so this equation is satisfied from both sides. Sine theta 2, this equation is satisfied from both sides. Let me rub it. This one, yes, this equation is satisfied. Sorry, this is m1. This equation is satisfied from both sides. So now from this equation, I'll take this equation. So this equation is redundant. ये वाला equation कोई काम का नहीं रहेगा मेरे लिए. ये मेरे लिए कोई काम का नहीं रहेगा. ये वाला, ये J component वाला हट जाएगा. ये तो J component से आया ना. This equation has come from this. So I'll take this equation, and I'll take one more equation. I will take the coefficient of restitution equation. I'm talking about this equation. I'll take this equation into consideration. These two equations I'll take. And when I solve them, let me write it down for you. Let me copy it and paste it there. Wait. Wait a minute. Wait. Just a minute. Let me write it down there at the end. Wait a minute. It's difficult to paste. Let's write down. We have got these two equations. One equation is m1 u1 cos theta 1 plus m2 u2 cos theta 2 is equal to m1 v1 sin theta 1, cos theta 1, cos theta 1, cos phi 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 1 plus m2 v2 cos phi 2, cos phi 2. Let me write costs properly. Wait a minute. Let me write this cost properly. Cos phi 2. Now this equation, and I'll take this equation, the one I wrote. V1 cos phi 1, cos phi 1, okay, and I'll write minus V2 cos phi 2, and I'll write E, you have U2 cos theta 2 minus U2 sine theta 2. Now these two equations I've got. Now I'll solve them. See, what I'll do is that what I know U2, I know U1. This is cos theta 1. Sorry, this is 1. I know U2, U1. I know the angles. I know all the angles. I only have to find V1 cos phi 1, and I have to find V2 cos phi 2. If you now do one thing, you do one thing is that you write the equation in the reverse order. I mean to say, you write it this equation and you take this equation in this manner. E u2, E u2, I'm writing this side. मैं ये वाला साइड उधर लिख रहा हूं, अब देखो cos theta 2 minus u1 sin theta 2. मैं ये वाला इक्वेशन उल्टा घुमा रहा हूं. I'm rewriting it in the opposite direction now. See, v1 cos phi 1 minus v2 cos phi 2. Now see one thing. I need to simultaneously, I'll do one thing. I'll multiply this with m1 one time and then with m2 another time and add and subtract. Then what I'll get, I'm giving you the result directly. You can try on your own from this 4 and 6 equation, because this is, now let's drag it a little bit. I'll show you what I'm saying. See, suppose I want to find v1 cos phi 2. I'll do for 1. I'll try to do for 1. v1 cos phi 2, phi 1 I want. So this I want, this is also here. What is here multiplied? What is here with V2? Cos phi 2 M2. I'll try to multiply this whole equation by M2. See what happens. Write down. M1 U1 cos theta 1 plus M2 U2 cos theta 2 is equal to M1 V1 cos phi 1 plus M2 V2. I'm rewriting, wait a minute. I'm rewriting this equation. I am rewriting this equation now. Now V2 cos phi 2, multiply this equation by M2. What will happen? M2E mu 2 cos, let's open the brackets. Fully open the brackets now. Let's open the brackets. Now you have E U2 cos theta 2 minus M2 E U1 sin theta 2 is equal to M2 V1 cos phi 1 minus M2 V2 cos phi 2. Now you do, see, I did this multiplication with M1. I'm adding these two equations now. Now you see what happens. Let me take more space and make you understand. See what is happening. Now you add this two. Add these two. So what will happen? This will cancel out. This will have M1 plus M2 V1 cos phi 1, right? And here you try to take with one with 2 and the other with this C. This will be, take this one. This is U1 and this is U1. Now do one thing. You write M1 minus EU1 sine EU1. You take U1 cos theta 2. You take U1. You take, now you see sine theta 2 is also there. No, I made a mistake. Wait a minute. I made a mistake here. It is to be cos theta, not sine theta. Here I made a mistake. Wait a minute. I made a mistake here. That's why. Wait. I made a mistake here while writing. Sorry. So this has become cos theta 1. So this will be cos theta. Oh, wait a minute. Yes. We have this cos cos theta 1. Oh, wait a minute. This also will go off. This will be cos theta 1. Now see, you have u1 cos theta 1, you have u1 cos theta 1. So what you have got? m1 e yes, you have now, very simple. Now you have e m2. This is now e m2. It is bit complicated equation. It takes time. E m2. See, I've taken this and I've taken this one. So m1 minus e m2. I've taken this two. I've taken e m2 and u1 cos theta 1. This has come. Now plus, now you have m2 u2. See, u2 cos theta 2, u2 cos theta 2. You can take this. This is m2 plus uh, em2. em2, sorry, em2 cos theta 2. u2, this is will come in the bracket. Let me rub this portion. I need space here. Wait. This will come out to be u2 cos theta 2. u2 cos theta 2. This is 1. So this is going to come out m1, m2, v1 cos phi 1. This is coming out to be this. Now, cos phi, I want v1 cos phi 1. I want v1 cos phi 1. Let me drag it. v1 cos phi 1 comes out to be m1 minus e m2 u1 cos phi 1 cos theta 1, sorry, cos theta 1 plus m2 plus e m2 u2 cos theta 2 by m1 plus, this is m1 plus m2. Similarly, you got this equation, very, very important equation. Let me mark it. This is the equation you needed. This is the equation you needed. Now suppose angle is 0. Cos 0 is 1, cos 0 is 1, and E is your 1. For a perfectly elastic collision, you will get that expression. E you put 1, theta 2 you put 0, theta 1 you put 0, all the angles you put 0, then you will get that equation for elastic collision if I put equal to 1. Let me write it down. For one dimension, see, from here I'll get elastic collision one dimension. See, elastic one dimension, 1D, I'm writing in short. You take phi 1 equal to theta 2 equal to theta 1 equal to phi 1 all as 0. So what will you get? V1. You will get an perfectly elastic E equal to 1. So you will get m1 minus m2, and then you will get u1 plus m1 plus m2 plus m2 will become 2m2, and you will get u2 upon m1 plus m2. I hope you have got that equation which I did in the earlier lecture. So this is how you get it. Now do one thing. You take multiply. See, I multiplied here. I multiplied this equation by m2. Now you do with m1. Now you do with m1. Now you do with m1. Now you do this equation with m1. You do this equation with m1, and you will get the next equation. You will get the next equation here. You will get the same type of equation. This is one equation. You will get the other equation as v2 cos phi 2. Now this would be equal to, this will be equal to m1 minus e m2, m1 minus e m2 u1 cos theta 1 plus m1, sorry, there is a mistake. I made a mistake here. Wait a minute. Yes, we will rewrite. This will be v2 cos theta 2 will be m1, just the opposite of that. M1 plus e u1 cos theta 1 cos, let me rewrite this, cos theta 1. It's a very cumbersome equation. Cos theta 1, you need to have a practice before the examination if you want to really do this in the examination. If they ask you e m1, this will be u2 cos theta 2 upon m1 plus m2. Now similarly, I'll rewrite this equation here, this equation down, and I'll tell you. See, rewrite that equation down. This is one equation for you. The other very important equation is v1 cos phi 1 is equal to, we got m1 minus e m2 u1 cos theta 1 You can take m2 common from both. One, you can see here, you can see here, if you take m2 common from both, you will get this. You will get this u2 cos theta 2 upon m1 plus m2. This is the collision problem. One equation. These two equations are of great importance in oblique collisions. I'm talking about two-dimensional collisions. This equation, this equation, wait a minute. Let me draw the line for you. This equation and this equation and this equation, these two equations are very, very important equation in two dimension. In two dimension, these two equations are the most important of all. Now you got V1 and V2. Now you've not actually got the total equation. Now still, because you have this point here. I hope you will remember. Let me see. Yes, just a minute. Yes, wait a minute. Yes. Yeah. This, yes. I have to place this u1 v1 cos and into this equation. I have to put those values here, especially in here. Wait a minute. I know these values. I know these values. I know these values. I have to put here in this part. I have to put this v1 cos phi 1 and v2 cos phi 2. Sin phi 1 and sin phi 2 I know because they are same as this. Look, I just did this calculation here that v1 sin phi 1 is u1 sin theta 1 and v2. See this calculation. This calculation. So I need not find the second this sin theta 2. These calculations are there already with me. So I need not do this calculation anymore. Now your vector, let me write down. Yes, let me keep it here a little more. Yes, here. Now let's write down the vector v1. The vector v1, let me write with the green pen. No problem. Vector v1 for, let me use this v1. The v1 cos phi 1, where I had v1 cos phi 1 I cap minus v1 sin phi 1 j cap. This is just put the value of this into this equation. So this becomes, let's write it down here, m1 minus e, wait a minute, m1 minus m1 minus e m2 u1 cos theta 1 plus m2 1 plus e u2 cos theta 2 upon your m1 plus m2. This is your I component minus v1 sin theta 1. You may write v1 instead of v1 sin theta 1, just as I told you they are equal here. I told you they are equal here. See, they are equal here. Where is it? Just a minute. Let me find it. Not here. Wait a minute. Just a minute. I did that calculation. Yes, here. This calculation is very, very important. Let me mark it. One calculation is this. The other calculation is this. These two calculations are very important. Instead of writing v1 sin phi 1, I can write u1 sin theta 1 because I know theta 1 and I know u1 also. I know these angles. So no problem. Now let's write it here. Yes. Minus u1 sin theta 1 j cap. This is my v1, actual vector v1. Actual v is this. This is my v1 vector actually. Now, similarly, I'll try to write down the V2 component. This was my V1. I'll try to write down the V2 component. Similarly, now I'll write it directly. I can write it directly for you. The V2 component. Similarly, you can do it as your homework by putting that in that. So you will get V2. V2 is, let me write with a different color. Let me write V2. V2 is V2 cos theta V2. V2 cos theta 2. Cos phi 2, sorry, just a minute. This is phi 2 I cap minus v2 sin theta sin phi 2 j cap. Now you know v2 sin theta is same as u2 sin theta 2. So since I'll just put the value of here, this will become m1 plus m1 common. You will get m1 common and 1 plus u1 cos theta 1 cos theta 1 plus m2 minus em1 u2 cos theta 2 upon m1 plus m2, this m1 plus m2 I cap minus, instead of this I can write u2 sine theta 2 j cap. Now I hope you understood. This is actually my v2 vector. This was my, these are my actual vectors. This complete one. Wait a minute. Let me see. Let me drag it a little down. Here, let me come to this. This is my actual vector v1. Actually, this is my the total actual vector v1. This one, this one, and now you have the actual vector v2. Similarly, you have the actual vector v2 as this one. Wait a minute. You need to draw this completely. You cannot skip even a line. This is what they are talking.